All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, we wrote the code to run our program for recognizing handwritten digits, and now we're going to read over exactly what we put into our code to implement it. So we're going to take it from the top. Now, yesterday we went over what the MNIST was, so we're going to skip that part. And there's a bit of reshaping we need to do, just turning the data into a format that we can put into our CNN. Now, doing things like taking all the values and dividing them by 255. Now, remember that the color values tend to range from 0 to 255, so we can divide them into 255 just to put them into a 0 or 1 range to make it a little easier to train on. That's this piece right here, prepare data for training. Let's move down. But here's an interesting and important part. Here's where we create our CNN. We're saying go ahead and use a sequential model. And before, where we had to use model.add, saying add a layer, add a layer, add a layer, etc., etc. Another way we can define it is by passing as input to our sequential neural network a list of all the layers we want. So this is our sequential model here. This is our first layer. That's not our first layer. That's our sequential model we're creating. This will be our first layer here. But before we get there, we're going to see that what's going on before then. So here the very first layer in our model is a convolutional one, where we're first going to apply convolution to our image. We're going to use 32 different filters. So our model is going to learn 32 different filters on the input image. This is our convolutional layer here with our 32 filters using a 3x3 kernel. And I told you the input shape was a 28 by 28 by 1. One, because we're only using black and white images, no color, so we don't need the full 3 channels of the RGB. So that's why that's one there. Then our max pooling filter means that we are going to look at 2x2 regions inside of the image and just extract the maximum value. We're only looking at 2x2 regions because that's what the size of our max pool is, a 2x2. So we know what the max pooling is, and that's the size of the filter we're going to be using for that. Now again, this is helpful because it will reduce the size of our input. Max pooling layer using 2x2 pool size, that's this. Now next we will flatten out all of the units into a single layer that we can then pass into the rest of our neural network. There's flatten units here, and then that's how we flatten the units. Let's go down a little bit further. And here's the rest of the neural network. Here we're saying let's add a hidden layer to our neural network with 128 units. And just to prevent overfitting, we'll add a dropout that says when we're training, randomly drop out half of the nodes from the layer just to make sure we don't become over-reliant on any particular node. This will help us generalize and stop ourselves from overfitting. So you can see here, this is our hidden layer, our 128 nodes, and this is our dropout specifying to drop half of the layers or half of the nodes in a layer with the 0.5. Our activation is going to be ReLU. Let's move down a little bit more. And then finally, hold on. And then finally, we add an output layer. The output is going to have 10 units, one for each category that we would like to classify a digit into. So 0 to 9, different categories. And the activation we're going to use here is called the softmax activation function. In short, what the softmax activation function is going to do is take the output and turn it into a probability distribution. So ultimately, it's going to tell us what do we estimate the probability is that this is a 2 as opposed to a 3 or a 4, and we turn it into a probability distribution formula. That's that part there. All right, and then we're going to train our neural network. It's still the same here. You see a model.compile, optimize equals atom, loss equals categorical cross entropy, matrix equals accuracy. Then we have, we're going to fit next, model.fit, x train, y train, epochs 10. We're going to evaluate the model.evaluate, x test, y test, verbose equals 2. Now here we've added to our Python program. If we provided a command line argument with the name of a file, we're going to go ahead and save the model to a file. This can be quite useful too. Once we've done the training, we could take some time, which could take some time. We like to remember all the information we learned so that we can use it later. So after we've done training on the model, we can actually save it to a specified location that we specify. And this can be quite useful too once we've done the training. We did that part already. And so TensorFlow allows us to save a model to a file such that later, if we want to use the model that we've learned, use the information we learned to make some new predictions, we can just use the model that already exists. So what we're doing here is after we've done doing all of the calculation, we'll save the model to a file such that we can use it a little bit later. So this is the save file here. Now, I should have known it wasn't going to work just by looking at it right off of the hand, but everything else did work. We did run the model here. These are outputs. So you can see we ran out with 10 epochs here. You can see here, this is our losses, it's our accuracy. And again, as our program trains, our accuracy gets better. So we go from a 0.93, we make it all the way to a 0.99 on the training data. And then this is our testing data. This is data that our model hasn't seen yet. This is the data that we're training. This is the data that we're testing our trained data on. So yeah, it hasn't seen this, and you can see this is how we test the accuracy of our model. You can see our test model here done a 0.03 loss and accuracy of 0.9904. So our model is performing quite well. Now you can see it's here down in our terminal also. When we get to this part when it's time to save to a file, you can see that we got a warning here and it didn't go through. Now, I should have known, like I said, that it wasn't going to go through because of the way it's written. As you can see here, it says if length since the argv equals 2. Now we should have known that wasn't going to work. And there's a clue down here that tells exactly why it didn't work. You can see here it says Mrs. Gates.png is not a directory. So what happened was we tried to use the same second argument line to save a file that we used to actually bring our photo over in a previous program. That's why I mentioned it here. So this was the second argument that we needed to bring our image over for our filters. And then this is trying to read that as the location we're going to send our file to. What I'm going to try to do probably tomorrow or later tonight is change this to a 3 and see if we can actually make it where we can specify the location that we want to go after to the third location, make our file location to arg3, and we'll see how that goes. If not, I'll just move some things around and maybe make it I don't know, we'll figure something out, but it's not that important right now. We know how to do it. We identified the problem. We know what's going on. But yeah, that's pretty much the gist of the night. That's what happened. But of course, we will pick it up tomorrow. I will keep you guys posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.